Hello and welcome to Design, Deploy, and Optimize SQL Server on AWS. My name is Vlad Vlaschanu. I'm a solutions architect with AWS, and with me on stage today I have Tom Staub. And together we're going to discuss some of the key best practices of running SQL Server on AWS, on our platform, as effectively as possible. And we do expect some baseline understanding as far as AWS core services. This is a 300-level session. And following that, our friends from DataVale and SONY, Blaine and Siva, will talk a little bit about their experience in practice, applying the best practices of deploying SQL Server on AWS, and also building upon that to build an effective solution that works for customers using SQL Server on AWS. We'll be talking a little bit about deployment options and talking about SQL Server on EC2 as well as RDS. And I'm focusing a little bit on SQL Server 2017 as well. Now, most of you are already familiar with the fact that we have two options for running SQL Server on AWS. We've got Amazon RDS for SQL Server, and you can run SQL Server on Amazon EC2. Now, both these options have their own values, and we absolutely encourage you to, evaluate both of them. But as you're doing that, and especially if your organization is adopting a cloud-native strategy, you'll see perhaps more alignment with one of these options, perhaps with RDS, where, we take on some of the operational burden that customers would otherwise have to do and have to work with when they're deploying SQL Server. And that would allow you to focus on things that really matter: optimization, focusing on the business value tasks. Now, there is a lot of value in having control as well. So SQL Server running on EC2 is a perfectly valid option for a lot of organizations, especially if they need system-level control, OS-level access. They need to manage backups and replication. They need access to the sysadmin role, or they simply need features and performance requirements or options that aren't available in RDS. So this really boils down to, the management aspect of it. The decision is, with RDS, we take on the management burden, whereas with EC2, it's a self-managed solution. You're the one that actually has to worry about HA, backups, operational, patching, so on and so forth. And all of the capabilities, recommendations, and potentially some of the limitations kind of follow out of that, right? And the responsibilities that we have and you as a customer have whenever you're picking one of these options also follow out of that. Now, we'll talk a little bit more about these throughout the presentation. So let's start with SQL Server on EC2. This is really a lot like running SQL Server in your own data centers. A lot of the best practices that are generally applicable to SQL Server anywhere you would run it apply to running SQL Server on EC2 as well. The couple of areas where we see our recommendations perhaps being slightly different is in the area of storage, in the area of high availability. So we'll focus a little bit deeper on those. So why storage? Because really, I/O contention is one of the leading causes of poor performance that we have seen whenever we're helping customers optimize on running these types of workloads on AWS. On AWS, we have a wide variety of storage options. We've got EBS with different volume times. We've got instant storage. They all have different characteristics in terms of throughput, in terms of latency, network storage versus local storage, and in terms of IOPS. So this makes them suitable to deploying SQL Server workloads to varying degrees. And on top of that, you've got different instance types, EC2 instance types, and they each have the newer instance types, they all have EBS optimization, which is a single dedicated channel for storage I/O. That one also has, based on the instance type, different throughput and I/O capabilities. In a way, it's great because it allows you to use the right storage technology for the right aspect of SQL Server. For example, typically we would use general purpose SSD volume for your boot drive, for your OS level drive. We would probably use provision IOPS EBS volumes for data and logs. This gives you predictable I/O and throughput performance. You'll probably use magnetic storage for the backup drives because those are workloads that are highly sequential in nature. And if available, you would put TEMPOB on instant storage. Now, this is very generic. Of course, your workload matters most. So, you might discover, for example, that you don't have a very high performance workload, so you could use general purpose for the D drive. Or on the opposite end of the spectrum, you might discover that you need you have such high IOPS requirements that you might decide to put the data and logs on instant storage as well to eliminate some of the network contention. So these are choices that you can certainly do. But at a very fundamental level, the throughput, the IOPS capabilities of your volumes from a storage perspective, and the throughput and IOPS capabilities of your instance matter a lot as far as how you're designing that storage solution. So given those four parameters, especially if we're talking about EBS, right, the EBS optimized throughput, the EBS optimized IOPS, the volume throughput, the volume IOPS, the fact that you can stripe, effectively a software RAID 0, multiple volumes together to get an aggregate multiple times the capability of a single volume, and the fact that SQL Server typically has high I/O operation sizes on average, right? If you're looking at perf mon counters, for example, you might actually discover that on average it's probably around 40 and 50 kilobytes on average I/O operation, which is more than the nominal 16 kilobytes that you see in our documentation whenever we're describing the performance capabilities of our volumes. So these matter, and here's what I mean by that. So here's an example of a storage solution for two different instance types. Really quickly here, which one do you think is the right solution? And that's a trick question because actually neither of these solutions are ideal. But they do illustrate the types of problems that you can encounter. So we have the R4 family of instances, right? They're very popular with databases. And at the smallest end, we have the R4 large. It gives you about 3,000 IOPS in terms of EBS optimized instance capability, and it gives you about 53 megabytes per second in expected throughput. Now, I'm provisioning a small workload, and I'm using one general purpose volume at 1 terabyte in size to store my data. And I've matched it nicely with the IOPS. You'll see that the IOPS are exactly the same on the volume as they are on the instance. But the throughput that volume can handle is actually 3 times more than the instance itself. So here we have a mismatch, right? So you're going to be the upper limit in terms of capabilities for that instance is going to be determined by that instance type before you can even achieve maximum throughput on the volume. And this matters for SQL because, again, SQL Server has higher I/O operation sizes. So you're likely going to actually saturate your throughput before you actually reach maximum IOPS in most cases. Now, at the other end of the spectrum, we have the largest R4 instance type, This is a much bigger instance, suitable for much bigger workloads. This one supports 75,000 IOPS as a maximum capability, and it delivers a maximum expected throughput about 1,700 megabytes per second. For this, this is a more performant workload. I've chosen to strive for 1 terabyte provision IOP volumes, each providing 20,000 IOPS individually, which gives me an aggregate capability of about 80,000 IOPS and 1,200 megabytes per second, almost 1,300 megabytes per second in throughput. Now, this is a lot closer match. You'll notice that from an IOPS perspective, I'm slightly over what the instance itself can handle. But on the throughput side, I'm well below that. And because SQL Server is most likely going to be, in many cases, throughput bound, this is actually a much better match for a SQL Server workload and a lot less of a kind of mismatch in terms of throughput and IOPS. Now, it's still not ideal, right? So you would still want to size those more correctly. But this kind of illustrates the types of decisions that you have to do in terms of storage optimization. And since we're talking about storage optimization, it wouldn't be complete if we don't mention TEMPOB. So one of the main recommendations around working with AWS is if you do have instance storage, move TEMPOB on instance storage, because you're eliminating some of the storage I/O throughput contention that you otherwise would incur just because of TEMPOB itself. A partner of ours, IFM out of New Zealand, actually published a solution that actually, when you deploy it, it actually goes in, mounts the instance storage volumes, it provisions the stripe, it formats them, and it configures SQL Server and then boots SQL Server. So it does basically everything for you. Now, this recommendation is obviously in addition to the standard recommendations as far as, using multiple TEMPOB files and so on. And now I'm going to let Tom talk a little bit about HA and DR for SQL Server.
Thank you, Vlad. So obviously, Vlad talked a lot about storage optimization, all very important things. But if you only have one instance and that fails, you're dead anyway. It doesn't matter how well performing it was. So HA and DR, absolutely critical considerations and very powerful considerations in the cloud. The first aspect of this that we always talk about with AWS is our availability zones, because this gives you a capability that you're not going to find in your on-premises environment or most other places, because we have 16 different regions with 44 availability zones. Every region has at least 2 availability zones. And these zones are not separate racks in a data center. These are not different rooms in a building. These are separate buildings that are miles apart. These are data centers that have separate power grids, separate floodplain, and still we have such low latency between them that you can maintain a synchronous commit for SQL Server or other workloads. And other workloads. And what that enables you to do is, as you probably already know, you need that synchronous connection in order to do high availability, in order to do automatic failover. So what we're going to talk about is a couple of options that leverage the multi-AZ capability, utilize that HA capability, that also provides a little bit of DR, and we'll talk more about that. With Enterprise Edition, you have availability groups, and with Standard Edition, you have failover cluster instances. And we'll talk more about that. Failover cluster instances, as you may be aware, utilize shared storage. We do have a solution for that through a partner of ours, and I'll get into that in a few slides here. So let's first talk about availability groups. This is a best practice configuration for availability groups, or one of them, I should say. In this particular case, we have Active Directory set up on EC2. Another option would be to utilize our directory services for the Active Directory part for managed AD. But in this case, you'll notice that we have the Active Directory nodes split in multiple AZs. You see there are 3 availability zones within this one region. So you have that low latency in everything you see in this picture. So we have 2 nodes for the Active Directory, and then we have our 2 nodes for our availability group. The third, in this case, in order to maintain quorum, we're using a file share. If you wanted to have, we're talking Enterprise Edition here, if you wanted to have 3, 4 nodes, absolutely not a problem, as long as you can afford it. And then, obviously, in that case, if you have 3 instead of the file share witness, we would recommend that the third replica be in the third AZ. If you want to expand that to another region, you'll notice on the left-hand side, it looks exactly like what we just talked about. But now what we've done is we created a VPN tunnel that enables us to extend to the third, extend that to the additional region, and we extend the Active Directory and extend the availability group. Now, I mentioned the low latency, automatic failover, high availability, all true when you're talking multi-AZ within one region. As soon as you go multi-region, now we recommend an asynchronous commit, and therefore you're doing a manual failover if that's the case, if necessary. So within a region, HA, and even a bit of DR because of that geographic separation, but then with the larger separation with multi-region, now you're looking at pure DR capability. And then our additional option is failover cluster instances. And in some ways, this is my favorite. It does have some limitations that availability groups overcome. Failover cluster instances are a pure failover feature within SQL Server. So your secondary node is purely passive. Availability groups allow for readable secondaries. So if readable secondaries are important for you, you're going to go Enterprise Edition, you're going to go with availability groups. But if cost is a bigger factor and you don't need those readable secondaries, Standard Edition is supported on a 2-node failover cluster instance. Now, I mentioned before this requires shared storage typically, but a partner of ours, Sios, they have a product, Sios Data Keeper Cluster Edition. And what it actually does is it takes this to the next level. Because instead of sharing the storage, where normally you'd use a SAN in a data center, this allows you to replicate your EBS volume to another EC2 instance. And of course, following our best practices, that other instance is going to be an availability zone. So now your storage is multi-AZ, not just your compute node. And this allows us to have that same HA capability, but now we're using Standard Edition. Now again, you don't have readable secondaries. This is configured at the instance level. So one advantage to this over availability groups is if I change a schedule for I change one of my jobs for a SQL agent, if I do that with availability groups, I need to remember to change that in all of my secondaries because jobs are maintained in the MSDB database, which is a system database, and by definition, availability groups do not include system databases. But, I'm sorry, can we hold questions till the end, please? This is a multi-subnet cluster. So they have separate IPs. There was a question about virtual IPs with the cluster. So this enables us to have that high availability scenario that's really an enterprise level capability, but still using Standard Edition. Now let's take a look, talk a little bit about Amazon RDS. As Vlad mentioned earlier, this is our managed relational database service. From a SQL Server perspective, you have a lot of the same capabilities that you have with EC2, but there are certain restrictions and certain differences. And as Vlad mentioned, the key advantage here is a lot of these things are managed for you. So we'll talk a little bit about the same things we talked about with EC2, with the storage and throughput, and then some about the high availability. So the exciting new news, I don't know if anyone's seen this. This is really only a week today, we said. A week ago today, this was just announced scalable storage with SQL Server RDS. So this means you don't have to absolutely know up front exactly how much storage you're going to need, and if you were wrong, then you've got to do a backup and restore to a different size. You can scale that storage just by modifying the instance now. It's a great new capability. Relatively new news, but not as new as that. A few months ago, we announced an increase. Maximum storage is now 16 terabytes on RDS, and maximum IOPS of 20,000. And you're going to have very similar. Vlad did an excellent job explaining this on EC2. You want to keep that in mind between the instance type and the storage type, and balancing that IOPS and throughput. And then CloudWatch is a very important aspect. CloudWatch works with a lot of our services, but if you're not familiar with it, it's a monitoring tool, and you can use it to get information like average queue depth, processor information, et cetera, to make sure that you're optimizing your workloads. So, availability groups, failover cluster instances, great solutions for EC2. So what do you do on RDS? Well, again, the beauty of RDS is it's managed. What you do is you check a box. You just choose an option that says, I want to be multi-AZ, and everything else is done for you. It's automatically set up multi-AZ, so you have that advantage. There's a witness set up in the third AZ, and mirroring is set up between the two. You have automatic failover because, again, we're talking multi-AZ, not multi-region here. So you have that automatic failover capability. So how does that work? Well, first, if a failover does need to occur for any of the reasons mentioned here or for any other reason that might come up, the mirroring is stopped. You need to promote the secondary to become the new master. The DNS input is then changed, and then a new secondary is provisioned. Now, my favorite feature with RDS is actually this last tile here, provision new secondary. Because anyone who's familiar with working on premises, anyone who's familiar with working with EC2 or any other environment like that, when a failover occurs, you're happy, you're excited, great, I configured this perfectly, and everything did exactly what I wanted it to. I lost nothing, and we're good to go on the new instance. Except now you don't have HA if you only had 2 nodes. If you had 2 nodes, your failover occurred, you have 1 node now. With RDS, we have what's called automatic host replacement. And that's what's doing this last tile here. You do not provision that new secondary. It does it for you. It's a managed service, so we're going to provision that new instance for you. And now I'll let Vlad talk about some of the other features with RDS.
Yeah, thank you. So, and we talked a little bit at the beginning about the fact that it's a managed service, and part of it is lower operational overhead for customers. One of the aspects of that is managing and configuring and maintaining the configurations of your SQL Server. So in a traditional environment, you would go in there, and if you have to configure SQL Server, you would change the parameters wherever they live, in the database, at the OS level, registry, wherever. But that doesn't really give you accountability over time, right? So problem is that over the years, somebody might log in, tweak a setting somewhere, and move on, right? So you're diverging from what you think it was the actual configuration of that cluster over time. With RDS, we offer a centralized way to manage these configurations. So we have parameter groups that are a central way of going in and actually setting exactly what configurations you want for all of those database engine flags. Now, we provide default parameter groups that are good for most workloads, but you can actually create your custom ones as well. And the best thing about that is you can apply that to one RDS database server, or you can apply it to 100 servers. And at any given point in time, if you're not sure exactly what configuration is running on a specific server, you go and check out the parameter group that's associated with it. Now, the defaults that we provide are, are based on vendor recommendation, based on the SQL Server community recommendations. So they're designed to be effective for maybe 80–90% of the workloads. There's certainly situations here where you should go in there and customize them. But when you do go in and customize parameter groups, we want you to do that because you actually have a clear and quantifiable reason to do that. You've done your due diligence, you've done your testing, and have recognized that if you tweak this parameter here, maybe it's max workers per thread, who knows, right? You've seen a quantifiable positive impact to your instance. A lot of situations, what we see is we see parameter configurations inherited over the years, over the different versions, and kind of inherited over time, right? At some point, somebody, maybe 10 years ago, made a change to your parameters and decided that there was a positive impact. And this has been inherited through the organization this way, and nobody else paid attention. Nobody else went back to do the work and figure out if it really has the impact still in the current version of SQL Server. So we want you to be diligent about that. So make these changes, but only when they actually have a positive impact. Use this opportunity to actually kind of start with a clean slate and see if you even need to change these configurations. And then finally, we also have option groups. And these are used in a similar way to enable additional features. For RDS SQL Server specifically, the two features that get enabled this way are transparent data encryption, if you have Enterprise Edition, or our S3 backup and restore feature, which allows you to essentially back up to standard SQL Server .back files that are then shipped to S3, or restore from files that are sitting in S3. So you have to specify a couple of configurations there, which S3 bucket you want RDS to interact with, what sort of encryption options you want to use, and give RDS SQL Server permissions through a role to actually interact with S3. Now, just because you use RDS and it's a managed service, you still have capabilities to move data around, right? You can use the back files that we just talked about to import and export data out of RDS. And honestly, if you can take the downtime, that is by far the simplest way to move to RDS or move out of RDS, for example. It's a native tool. It's really easy to use, and it's going to be your simplest migration path. But it's not the only path. You certainly can use and export data in flat T-SQL files, and you can use, if you need minimal downtime style migrations, you can use our AWS database migration service. This one allows you to stream changes into RDS using change data capture, and it allows you to do migrations that are heterogeneous in nature as well. So moving from Oracle to SQL Server, or moving from MySQL to SQL Server, any sort of combinations like that. And then finally, we do have a very strong offering in the AWS marketplace, where there are third-party vendors offering data import and data export and movement tools and solutions that are also very powerful options for your workloads or for the specific use cases that they were designed to. Now, before we let Siva and Blaine talk, I wanted to spend a few minutes talking about SQL Server 2017. This is, it just came out about 2 months ago. And the awesome thing about it is on EC2, we supported SQL Server 2017 within 2 days of it going GA. And we now support SQL Server 2017 on RDS as well, less than 2 months from it going GA, which, considering that RDS is a managed service and requires so much more validation, it's really awesome, right? It's the least amount it ever took us to actually offer the newest version available. And one of the features that gets probably the most amount of attention about SQL Server 2017 is support for Linux, which is also available on AWS. You can deploy SQL Server Linux on Red Hat Enterprise Linux with license included, just the way you would do with the Windows version. For other distributions that are supported, such as Ubuntu and SUSE, you would have to install SQL Server and bring your own license and follow basically using the package manager that's relevant for that distribution. Both cluster and clusterless availability groups are supported on AWS, and cross-database transactions are supported now by always-on availability groups, which is available for Amazon EC2, and automatic plan correction and the graph database capabilities of SQL Server 2017 are supported on both EC2 and RDS. Now, a final word about using SQL Server 2017 on Linux, for those unfamiliar. The system databases are fixed to that path over there, var opt MS SQL data. Microsoft is hoping that they would potentially correct that and change that in a future cumulative update, but so far that's locked to that path, which really means, because on Linux people tend to commission very low and very small boot partitions in terms of size and IOPS and throughput capabilities, you probably want to mount a different EBS volume at that particular path location, just to make sure that you have enough I/O throughput if you're heavily using some of those system databases. Now, in the Linux world, of course, we've seen customers actually just keep all of their data files in that path location, not just the system files, and simply just mount their high-performance EBS volume potentially, or instance store volume against that path directly, right? So that they don't have to worry about that. And now I would like to invite Blaine and Siva to the stage. And they can tell you a little bit about how Sony and DataVail are using SQL Server and deploying it on AWS. Just the green button.
Hi, everyone. This is Siva from DataVail. DataVail is one of the largest database managed services company in North America. And we provide database managed services for different database platforms that include SQL Server, Oracle, MySQL, and Postgres. I have been with DataVail for the past 10 years, and I'm focused on performance tuning, database scalability, and also help customers move their Microsoft workloads to AWS.
Thanks, Siva. Sony DADC New Media Solutions is an industry leader in the digital supply chain. We went in 2017 all in with AWS, and we've just delivered our 10 millionth asset. We have over 1.2 million hours of premium entertainment content from over 450 distinct content owners. Venue is our content management, distribution, and OTT solution, leveraging integrated commerce solutions to provide an end-to-end platform for our clients and partners. My name is Blaine Baker, and I manage the business intelligence and reporting team for New Media Solutions. I've been providing technology expertise to the media and entertainment industry for the past 9 years and worked in the public sector prior to that. I perform the database architecture role for New Media Solutions and engage with DataVail on the day-to-day care and feeding of our database infrastructure. So some time ago, our primary DBA left the company, to pursue other opportunities. Our senior technology leadership consulted with key technologists in other Sony business units to kind of find out what their experiences were with like database administration providers. And we were looking for a partner with an established track record of migrating databases to AWS specifically. So Datavale came highly recommended through another Sony business unit, and we brought them on board to take care of the day-to-day care and feeding of our on-premise database infrastructure. So prior to our migration, our application and systems were designed to handle only the busiest times of year for our clients. And the problem with that approach was that throughout the rest of the year, the systems went underutilized. So our primary goal with our cloud migration was to be able to minimize our costs during those periods of low activity, but then be able to painlessly scale out our application footprint during those periods of anticipated high activity. Let me go ahead and, yeah, there we go. So the timeline for the migration was driven by our contract with our traditional hosted data center and also our ability to migrate a 20 petabyte archive of digital content from LTO tapes up to our chosen cloud provider. And now we talked to all the various cloud providers, and we identified that only AWS could provide the storage throughput and capacity required both for our platform and also for our migration activity. So there we go. So hopefully now you kind of have an understanding, put yourself in my shoes and find out like what are the expectations and the challenges involved in performing a cloud migration. So at this point, you probably have some thoughts of your own since you joined us today about your own challenges and want to understand how we achieve this migration with Datavale. So at this point, I'm going to go ahead and turn the presentation back over to Ziva.
Thanks, Blaine. Database migration. One of the requirements we had as part of the database migration was to choose between RDS and EC2. We spent quite a bit of time in figuring out what would be the right choice, and I think Tom went over the advantages of like choosing RDS versus EC2. Because the application and also the new media solutions, they had a dependency on some native Microsoft SQL Server features like CLR, linked server, and change data capture. We were not able to use RDS, so we decided to migrate to AWS EC2. One of the other requirements we also had was how to move 2 terabytes of data from on-prem to AWS. We initially explored using AWS database migration services, but we had some data center network configuration issues, so we decided to use S3, and we decided to use the traditional backup and restore strategy. So what we did was we migrated an active passive cluster running on-prem to multiple EC2 nodes running on AWS. We also decided to upgrade from SQL Server 2008 R2 to SQL Server 2014 so that we can leverage the always-on availability groups in the AWS architecture. I'm going to talk more about always-on availability groups and how we leverage some of the features. So the major factor that triggered us for the migration, or the main driver for the AWS migration, was the cost reduction. We took several steps to reduce the cost. Outside the database layer, Blaine and the team, they chose the right-sized Amazon EC2 templates, at the same time taking advantage of the spot instances, and they also used auto-scaling groups to minimize the cost. Within the database layer, we chose the R3 high-memory Amazon EC2 templates with provisioned IOPS, and we ran in production using an on-demand model until we were very confident in our configuration. Once we were very confident in our configuration, we decided to go with the reserved instances to further reduce the costs. The other major driver in the migration process was to solve the HA and DR problem. On the on-prem environment, although we had an active passive cluster, it was not truly like HA and DR capable. So what we decided was we decided to deploy the EC2 instances in a multi-AZ inside a single region. We also leveraged the Amazon S3 and Amazon Glacier for storing backups and restore it from them. We also leverage the auto-scaling groups within AWS, and Blaine is going to talk more about that in the upcoming slide. Initially, we proposed adding another region to this whole configuration as a part of DR process, but we were challenged with like finding another cost-optimal solution. So what we did was we recommended putting another third node in the same region, and also like use S3 and Amazon Glacier for storing backups. So we were able to get around it. So our approach was, the first major step we took was to do a performance baseline on the current server that's running on-prem, and then we use the multi-AZ capabilities and auto-scaling groups in AWS. The next step we took was to upgrade the SQL Server from 2008 R2 to 2014 so that we can take advantage of the always-on availability groups. We decided to use the Amazon S3 and Amazon Glacier for long-term backup storage in our kernel process. We also leveraged S3 for transferring the backup files from on-prem to AWS. Performance baseline. This is a very high-level overview of like all the metrics we used in collecting the performance baseline. So you can find the details of each performance counters online. So basically what we did was we ran the performance counters for a period of 4 days, and we calculated the minimum, maximum, and average values for each counter over the period of 4 days. This is a very important step in our migration process because this really helped us to choose the right instance type. After we ran the performance baseline, we decided to go with the R38X large instance type, which has 244 gigs of RAM and 32 virtual CPUs. We decided to go with the combination of general purpose and provisioned IOPS EBS volumes. And the ETL process, Sony DADC and MS, they had a requirement of like offloading the read-only queries to a different node. In the previous configuration, we were using replication and also like change data capture. So we were trying to solve that problem, and at the same time, we were also trying to solve the problem of HA and DR. So what we did was we configured the synchronous commit in the always-on availability groups, and we also configured read-only routing in the AAG so that the read queries can be routed to the secondary replica. And as far as HA goes, we configured the automatic failover to the synchronous node, and we used auto-scaling groups to automatically replace the fail node at each primary replica level. As far as the cost optimization goes, we used the reserved instances for production and staging service, and we used the on-demand instances for test and development service so that we can shut it down after the business hours. Backup and storage, we retained the 7 days worth of backups in Amazon S3, and we retained 90 days worth of backups in Amazon Glacier using automatic lifecycle management policy. This is a schematic of the proposed architecture and also the architecture we implemented at Sony DADC. As you can see, there are 3 EC2 nodes running Microsoft SQL Server deployed on 3 different AZs. I'm going to call the node that's running on AZ1 as a primary replica, and the other nodes are secondary replica. As you can see, there's a synchronous AAG configured between the primary replica sitting on AZ1 and the secondary replica sitting on AZ2. It is used for HA purposes, and we also configured the asynchronous AAG between the primary replica sitting in AZ1 and the secondary replica sitting in AZ3. One of the other interesting thing we also did was we configured the read-only routing at the AAG listener level. So the client application basically connects to the AAG listener. Both the OLTP workloads and also the reporting workloads, they connect through the AAG listener. As you can see, the read and write queries are automatically routed to the primary replica, and the read queries are routed automatically to the secondary replica in AZ2. We used S3 and Glacier for backups, and I'm going to defer to Blaine to talk more about how they leverage auto-scaling groups to automatically replace the fail node at each AZ.
Sure, so you may already be familiar with auto-scaling group as a mechanism for handling your application load. You set some thresholds, and then once the application exceeds them, it'll spin up new nodes and distribute the load. What you might not have considered is to integrate this as part of your disaster recovery strategy. So consider a scenario like this one where you have a cluster with some nodes, and something happens to terminate one of your nodes. There's an issue with an AZ, or the node itself is terminated for whatever reason. The high availability features of SQL Server and the Windows failover cluster, they're going to take care of you at the database layer, right? Just like Tom was talking about earlier. your failover is going to happen. You'll have a blip where your application isn't connecting, but then you're connecting and you're good. But then you're left with that problem, right? What do I do with my failed node? Well, if you wrap each node in an auto-scaling group with a minimum and maximum number of nodes equal to 1, what you can do is start that provisioning process automatically. What you can do further from that is to leverage the user data in your auto-scaling group to add any kind of level of automation that you're comfortable with. You can do the configuration and naming of the node. You can join it to your Amazon directory service, running in Microsoft AD mode. You can do your unattended SQL Server installation, patching. You could download your S3, your backup stored on S3, your full, your differential, your translog. And if your environment is predictable enough, you may even be able to go so far as to start doing restores. There's a lot of automation capability that you can put in there to get yourself as close as you want to get to rejoining your new node back to your always on availability group as a secondary, in the secondary role, and then you can choose to do a failback or whatever you want to do at that point. So I would consider, everybody consider that in their own architecture to kind of streamline that recovery process as part of their overall database disaster recovery implementation.
Migration activities. So after the migration was completed, we were really interested in finding out how the new system was performing. So we again did the performance baseline using the same metrics that we did in on-prem. And we noticed there was a 30% improvement in the performance, and we were really happy with that. And apart from this, we are also doing ongoing performance tuning, rewriting some of the stored procedures, functions, and queries. We're also doing weight statistics analysis periodically, and we're also doing some TEMPOB optimization as required. Apart from that, DataVale has been also providing 24/7 database monitoring and alerting for SONY DADC. And we are also doing a very aggressive index and statistics maintenance every week. And we are also assisting SONY with several database-related tasks during their sprint release, which is every 1 month or 2 months. And with this, this is the end of the presentation. I will open up the floor for any questions.
Thanks.
Oh, yeah.
On your previous slide, you had 2 replicas. This may be asking too much detail, but did you purchase your SQL licenses, or did that actually end up saving you on the licensing cost for one of your replicas?
So we're licensed per core, but I am not recalling if it made a difference whether we used an asynchronous. I don't believe that was one of the considering factors when we were building that out. Right, the asynchronous. So we're doing our reads from the synchronous node.
Just to answer that question in general in terms of the way the licensing works, if you have software assurance with Microsoft, and you have to have software assurance though, but if you have that, then they give you a benefit of 1 free passive node. So in this particular case, the readable secondary would not qualify, but that other secondary being only passive could qualify for that, but you would have to have software assurance in a BYOL scenario.
Yes, sir.
Did you have any performance concerns with going asynchronous AD across availability zones? I don't know what your throughput requirements were like, but did you see any sort of performance impact on the application that way?
So the question was in reference to, do we have any performance concerns about the latency between the 2 availability zones for the primary node and the synchronous secondary? In practice, we haven't been experiencing it to the extent that it's been noticeable. I think it's been single-digit millisecond. It's been performing very well. So there isn't an example of where we might have a dashboard that is going to do a read query, and we see some stale data because it's not coming over fast enough. That has not been a consideration, or that hasn't been any issue that has surfaced since implementing this configuration. No, not at all.
Before we move to the
sorry.
before we move to the next question, I just want to also add a couple of things to what Blaine said. So yeah, there was no impact on the application performance, but however, sometimes when you're running the read-only queries on the secondary replica, if those queries are blocking, say if you're running a big query, those queries are blocking the redo logs, which is constantly applying on the secondary replica, then you might see there's a big latency going on. So you want to check probably if your redo log is pretty long. If it's long, then you might want to find out what's causing it. but that not necessarily causes a delay in your primary replica, actually. That will cause probably like a latency in the secondary replica, and your reports probably they are not like more like real time based on the latency.
Yes, sir.
So you're continue to push using instant storage for 10 TB, but you're using R4 as your examples. And it looks like, at least in the R class, you're going away from instant storage. So
Right.
where are you going next?
So the idea with pushing TEMPOB to instant storage is if it is available and do it, you're just eliminating some of that. But realistically, what we're seeing is with customer that at this point, EBS storage becomes fast enough in terms of I/O latency, in terms of throughput, and in terms of capabilities that you would get the same performance, right? And if you're looking also at some of the newer instance types, their EBS optimized channel capabilities are much, much larger, much more bigger than older instance types. So it's really, it's a bit of a trade-off, right? But as you're going to newer instance types, you may not necessarily have to depend on instant storage as much, right? On the older ones, it does have an impact, like on an R3 instance class, for example.
Just to add to that also, and this is only just a few weeks ago, we extended the X1E family to smaller instance types. So in September, we announced the X1E 32X large, 128 cores, 4 terabytes of RAM. That might be a little overkill for a lot of workloads. So now we've extended that all the way down to 4 cores and 122 gigs of RAM, or my personal favorite, 8 cores and 244. It's my personal favorite because it's fantastic for SQL Server Standard, because you can give SQL the full 128, the standard is the limit for standard, and you still have plenty of memory left available if you want to run reporting services, SSIS, that sort of thing. And those X1E instances have instant store and are EBS optimized.
Yeah. Yes, sir.
Has there been any best practice no-nos about putting buffer pool extensions and 10 TB in a federal like I3 or the X1 storage space together?
I don't think I've
I haven't heard, I mean, well, with i3 specifically of the
I mean,
NVMe,
it's
so-
something that you would want to test, and there's obviously a consideration around contention, but realistically, especially then, you want to test it, and if it works, you also can consider the fact that most of, except probably the lowest instances that have instant storage, most of them have multiple drives. So you can achieve some segregation that way because each drive would have its own channel anyway, right? So you might actually not have I/O contention that way. So I would certainly encourage doing that based on testing, of course.
So moving to the R4 then, for 10 TB, is there sort of a best practice to strike multiple EBS volumes to increase the performance to match the instant store?
I think when the R4 family, unless you're looking at the really smallest one of them, I would recommend you definitely stripe multiple EBS volumes anyway to get the aggregate performance. But it's going to be just a matter of understanding how much throughput and how much IOPS your TEMPOB is going to be consuming versus your regular workload versus data and logs.
So for our primary database, while it's uncompressed, it's very nearly 1 terabyte. Once it's compressed, it's about 300 gigabytes. There's a variety of ways that you can, first initially I capture it locally to a backup volume. It's a GP2 general purpose volume. And so what I do after that's been captured, there's a couple of mechanisms you can do. You can either go third party or you can try to use AWS CLI or whatever method you want to do to actually transfer the file up to S3. But I've integrated all of that into the backup SQL jobs. So When you do full backups, all the full backups get copied up to S3, and then the lifecycle policy will dictate, when it goes to Glacier and what have you. And then when I take my Translog backups, it's the same thing. And then I've got one of my databases has got a differential, once or twice a day, so that way all of that is available, because that just inherently, you have that backup volume, but it may not be there, right? So you need to know that as soon as you've got that backup, you're getting it up to S3 as quickly as possible, because that it's just a matter of time, right? Something may happen. So you want to have it available to any node that may fail, so that you can pull those down and get your recovery process going in the, cross your fingers, it's not going to happen, right? So, right, so we're back, so it's the same idea, right? So I have a SQL job that'll take the transaction log backups every so often to that volume, and as soon as it gets there, as soon as it gets onto the EBS volume, then that same job will copy those up to S3 immediately. We have not attempted that, no.
Yes, sir.
Or,
Mm-hmm.
I haven't seen any publications on anybody doing that. Or anybody who's doing that today. Is it really single digit?
So the question was, with the opening of the Ohio region, it's really close enough to Northern Virginia that you could potentially actually get low enough latency to do synchronous replication over between those two regions.
They suggested that. I don't
Yeah. I personally haven't seen
That's
a
the first
customer.
I've heard that.
I haven't seen a customer, but again, it depends on your workload a lot, and do a test, see if the latency that you're getting is tolerable, and more importantly, see if your latency is stable enough, right? Because the aspect isn't necessarily whether you can get the latency down to a desirable amount, whether that's predictably over a long term. And I think that's where you would have to make a decision whether that makes sense. We do have customers, for example, maybe not the most high performance workloads, but in migration settings, I've seen customers that actually always on availability groups as a method of migrating to AWS with synchronous replication, where they have the master on premise and using a direct connect or something else, push it over to AWS on the other side. That's something where you'd have to, obviously kind of weigh the pros and cons. The latency with direct connect can be predictable. It may not necessarily be low enough, but it might just give you the, given a short enough time, it might be tolerable for you to do the migration.
Yeah, just to add one point to that, Microsoft doesn't post rules per se on synchronous versus asynchronous. So there's nothing that would prevent you from doing a synchronous connection from here to Japan. You're probably not going to want to do it, but there's nothing that stops you. Yeah, absolutely, absolutely. But my point is, so back to what Vlad was saying, is it depends on your workload. It really comes down to testing an individual workload. There are some people that 2, 3 nodes all synchronous in one region is fine. Other people might not find that. I talked to one customer who they wanted to leverage the NVMe volumes on the I instance, right? On the I instance type, and they were putting their data files on the instance store, but then they had multiple, multiple synchronous nodes across the AZs and handled it that way. So we talk about most common best practices, but it doesn't mean it's the only way to do it.
And at the end of the day, what you have to worry about is the end user impact. And if you have the application that, the average response time's in the hundreds of milliseconds, and the variation between, the 10 milliseconds that you might be shaving off or you might be incurring at the database layer might not necessarily have so much of an impact on the end user latency, right? If it's high enough on the application stack layer. So RDS does full instance backup. So once a day, there is a snapshot taken of that entire RDS database instance, and then we capture the transaction logs throughout the day and give you a point-in-time restore up to about 5 minutes.
Snapshot is a storage-based solution?
Yes, so that's an important aspect. So if you were to restore an RDS instance, you have to restore that entire database. If you're using our automated snapshot and backup capabilities. If you're using the exporting back files to S3, you can certainly do them on a database level.
By default, if I'm giving services to RDS,
Yes.
so if I need any prototype results, we go through your process, right? I won't get a .BAK file, right?
Not unless you're actually exporting BAK files every. Yes. Correct. All of that is completely handled. So all you would do in case of a recovery event, you specify which instance you want to recover from. You specify the point in time, and we will essentially provision a new RDS database instance at that point in time.
I'm sorry, we can continue this discussion offline, but we need to wrap up here. But thank you, everybody, for your time.
Spend some more time out there.